Hello everyone, so welcome back to this video. So in this video we are going to learn how to use RSA digital signature algorithm to sign a document digitally. So we will use RSA algorithm to sign our document. The document that we are going to sign is an image file. So this is the image file that we are going to sign. So signing a document is a 6-step process, so which is given by here. So in the step 1 we will generate an RSA key pair, and the name of the key are the public key and the private key. So we will use private key to sign a document, while as we will use public key to verify the signed document. The first step is to generate a RSA key pair, and in the second step we will save this public and private key in their respective file name called private_key.pem and public_key.pem. And in the third step we will read this image file, and then we will assign this image file with this private key, and then we will save the signed image with a file name called digital_signature.bin. and after that we will verify this signed digital document by the equivalent public key. So without too much delay, let's implement this in our Java code. So in step 1, let's perform the step 1. So to generate a RSA key pair, I will define a static method. So the name of the static method will be the generate RSA key pair. So this is in line number 3. Let us define that method which will generate RSA private and public key. So to do that, let us define a static method, public static. The return type for this method is key pair, and the name of the method is generate RSA key pair. And then we will use key pair generator class to generate RSA key pair. And let us initialize the key pair generator with 2048 bit, as I want to generate 2048 bit private and public key. And then we will return this key pair, generate key pair. And let us also add throws exception here. Let me minimize this, and let us also add, so we have already added throws exception, so we don't need to add that. And so let us call this method generate RSA key pair, and then we can get an instance of public key and private key. Public key equal to key pair dot get public key. Similarly for private key, use private key class, get private key. So our step 1 is completed. So in step 2 we will save the value of private key and public key in their equivalent file named private_key.pm and public_key.pm. So let us define the static method named save private key and save public key. So the responsibility of these two methods is to save private and public key in their respective file. Public static void save private key to file, and the argument received by this method is private key. We need a private key, private key, and the path name where we want to save this key in a file, string file path. Okay, so now we got our private key and a file path. So now let us save this file. So to save this file, I will use file output stream. File output stream FOS is equal to new file output stream, and then I'll pass a file path here, and then use FOS.write method to pass our private key. So private key dot get encoded method. And now we also need to add a throws exception here to handle the exception. close exception, and then we need to close this resource dot close. So this will save our private key. Similarly, we can also use this exact method to save our public key. So I will copy this one and paste here, save public key. Public key to file, change private key to public key, public key, public key, and the file name is same. So public key, and we need to close our file output stream. So let us call our method here to save our private and public key. Save private key to file, and we need to pass private key, and our file name is, that is the file path is private_key.pem. and similarly we can call save public key to file, and then we can pass public key, public key.pm. So our step 2 is completed. Now in step 3 we will read our image so that we can assign that image using our private key. So this is the image. So to read the image we will use a file constructor. So file image file is equal to new file, and we will use the file name, that is image to sign.sig and sign.jpeg. So let us read this image in a byte array, and let us create a read image static method, read image data, and let us pass our image file path, and let us create this read image data which return the array of bytes of this image. So we will write our static method that will read our image path and return an array of bytes of that image data. So read image data, and this will receive our image path in file format. So file path is image file. The return type is private static byte array. So this method will read image data, and it will return the data of our image in byte array. So now we have get our image data in a byte array. Now in step 4 we are going to sign this image data using our private key. So to sign our data, let us create another static method named sign image. So private static, the return type will be byte array of our image data, and the name of our signature is sign image. The argument is array, byte array of our data, that is image data, and a private key. And let us handle our exception. So exception. So now we have image data and a private key. Now we can use this private key to sign our image data. So to sign image data, we need to import a signature class. Signature class from Java Security Framework. Signature is equal to signature dot get instance, and the algorithm is, so we are using SHA 256 along with RSA. So this is the algorithm that we are going to use to sign our image data. And then we need to initialize our signature object, signature.init sign, and then we need to pass our private key, and then we need to update our signature object with our data. So update, so we need to pass a byte array, so image data, and after passing a data and a private key, we have a sign method in a signature object, sign, and this method will return an array of signed data. So now we can call this method in our step 4, which will return the signed image data. Byte array, digital signature of our image is digital signature sign image, so we need to pass image data and a private key. So now we got our digital signature. Now we need to store this signed image in our file system. So to save this digital signature, let us create another method. The responsibility of this method is to save that digital sign into a file system. Private static void save file, and this will receive a byte array of signed digital data, byte array, digital signature, and a string of file path where we can save our digitally signed image. So to sign the image, we will use file output stream class. FOS is equal to new file output stream, and then we will pass file path. FOS.write, and then we will pass an array of byte digital signature, and then we will close our resource, close, and add some exception handling here. So now this method will save our digital signature in a file path. So let us call this method save digital signature to file. Let us pass the digital signature and a file path, and the name of our file will be digital signature.bin. Okay, so now in step 6 we will again read this digital signature.bin file, and then verified the sign inside this digital signature.bin file with our public key. So to do that, let us create another method that is called verify signature method. So the objective of this method is to verify the signed document by a public key. Statics, the return type will be boolean. If the signature matches, we will return true. If the signature does not matches, we will return false. And the name of the method is verify signature. The data will be the byte array of our digitally signed data, image data, and we also need a public key to verify this data. Public key, and let us add exception as well. So to verify the signature, we will again use the signature class. As we are signing with SSA 256 with RSA, So we will use the same SSH256 with RSA instance 256 with RSA, and after that we will initialize the verification signature.init verify, and then we will pass a public key, and then we will pass the data, image data, and then we will use the signature.verify, and then we pass the digital signature. So digital signature is not defined here. We need to pass the data, that is the signed data, that is also in byte format, byte signature, then return this status. So now let us call this verify signature method in step 6. Verify signature. So first of all we need to pass the image data here. So this is the actual original image data, image and data, and then we need to pass the digital signature, and then we need to pass a public key. So this method will compute the signed data and run against this signed data. If the public key matches the private key which is inside this signed data, then it will return true, else it will return false. So let us print out this out. So now let us run this code. As you can see, the program is building right now. So the signature verified is true. That means we are successfully able to verify the digitally signed document by a public key. And let us verify whether the respective files are generated or not. So as you can see here, private key.pem and private public key.pem are generated, and this is our digitally signed document. So you can pass this signed document to your friend or any other party and give them your public key and ask them to verify this digitally signed data by your public key. So thank you very much for watching this video. Thank you.